Hey everyone, in today's video we will be tackling one of LeetCode's most popular problems, daily temperatures. Whether you are preparing for coding interviews or just looking to improve your problem solving skills, this one is perfect to add to your collection. Let's dive right in. So let's take a look at the problem. You are given a list of temperatures for several days and your task is to return an array where each element represents the number of days you have to wait until a warmer temperature. If there is no future warmer day, you should return 0 for that day. Sounds simple, right? Let's break it down with an example. Let's understand the problem statement in detail with the help of this example. This is an input array where indices represent day and values represent temperature. This is an output array where indices represent day and values represents number of days to wait for warmer day. For day 0, temperature is 73. So next warmer day for day 0 is day 1 because the temperature on day 1 is 74, which is greater than 73. So the answer for day 0 is 1. Similarly, for day 1, answer is 1 because the next warmer day is day 2. For day 2, next warmer day is day 6 because temperature on day 6 is 76, which is greater than 75. So the number of days day 2 needs to wait is 4. So the answer for day 2 is 4. How we calculated this number 4? Simply we subtract the array indices, like 6 minus 2 is equal to 4. Similarly, we can calculate for other days. For day 6 and 7, there is no further warmer day. So we will simply put 0 in the output array for day 6 and 7. So now we understood the problem statement in detail. This problem is very simple with brute force approach. Let's quickly dive into the brute force solution. To solve this problem using brute force approach, simply loop through each day and for each day check all future days. Let's go through the implementation. Initialize the result array with all zeros. Size of the result array would be same as of input array. To for loop, outer for loop is to iterate through each day and inner for loop is to check for all future days. So inner loop starts from I plus 1. If temperature of j is greater than temperature of I, it means we found the warmer day for day I. So count the number of days by subtracting I from j and store the count into result and break the inner loop and repeat this process for remaining days. If there is no warmer day in the future, it remains 0 by default. So brute force solution is very simple, but the problem with this solution is it's very slow. For large input, this will give timeout issue. Let's copy and paste this solution into LeetCode. So this is a brute force solution. Let's try to submit this code. So out of 47 test cases passed, but this test case failed because the input is very large and we get time limit exceeded. So brute force solution is not accepted by LeetCode and also it is not expected in actual interview. So in actual interview, don't waste time in writing the brute force implementation. Only explanation is enough and move on with the optimal solution. Let's solve this problem in off n time using a powerful technique, the monotonic stack. In the brute force method, we are checking every day ahead, which resulted in of n square time. That is too slow for large inputs. So how do we fix this? Here is the trick. Instead of looking ahead blindly, we use a stack to keep track of the indices of previous temperatures in a smart way. This stack will help us remember which days are still waiting for a warmer day, and as soon as we find one, we resolve them immediately. Before we dive in, let's first understand what a monotonic stack is. A monotonic stack is a specialized stack data structure where the elements are always arranged in a specific order, either monotonically increasing or monotonically decreasing, depending on the problem's requirement. For example, so this stack is a monotonic stack because all elements are in decreasing order. But if you add 75 to this stack, then this is not a monotonic stack because 75 is greater than 50 and it's not in descending order. One more example. Again, this is a monotonic stack because all elements in a stack are in increasing order. But if you add 30 to this list, then it is not a monotonic stack. Now we understood what is a monotonic stack. Unfortunately, Java does not have a built-in monotonic stack. So we will make one ourselves using a regular stack and some clever math. Let's break down the solution step by step. Initialize empty stack output array, which is initialized to 0. Traverse the given list of temperatures from left to right. Current day is pointing to day 0. As stack is empty, push day 0 to stack. It means we haven't found the warmer temperature for day 0 yet. Let's move current day to next day. Current day is pointing to day 1. Compare day 1 with previous day. That is nothing but day 0. So 74 is greater than 73. It means day 1 is warmer than day 0. Let's pop day 0 from stack as we have found the warmer day for day 0. Calculate the number of days to wait by subtracting the indices. 1 minus 0 is equal to 1 and store the result in output array. If you observe, to calculate the number of days to wait, we simply need array indices. So no need to store values into stack, but for visualization we'll store both values plus array index and push the current day to stack as we haven't found the warmer day for current day. Now current day is pointing to day 2. Again do the same thing. Compare day 2 with day 1. 75 is greater than 74. Yes, we found the warmer day for day 1. So pop it from the stack. Calculate the days difference. 2 minus 1 is equal to 1 and update the output array and push current day to stack. Current day is pointing to day 3. Compare day 3 with day 2. 71 is greater than 75. No. Push the current day to stack. Now current day is pointing to 4. Again compare. 69 is greater than 71. No. Push the current day to stack. If you observe, all the elements in a stack are in decreasing order. This is why this is called monotonic stack. So let's continue. Current day is pointing to 5. 72 is greater than 69. Yes, that means we have found the next warmer day for day 4. So let's pop day 4 from stack and calculate the difference in days. 5 minus 4 is equal to 1 and update the answer. For day 4 answer is 1. Repeat this process until stack is empty or current day is not warmer. 72 is greater than 71. Yes, let's pop element from the stack. Calculate the difference in days. 5 minus 3 is equal to 2 and update the answer. 72 is greater than 75. No. Push the current day to stack. Current day is pointing to day 6. 76 is greater than 72. Yes, it is. Pop 72 from stack. Calculate the difference in days. 6 minus 5 is equal to 1 and update the answer. 76 is greater than 75. Yes. Pop day 2 from stack. Calculate the difference in days. 6 minus 2 is equal to 4 and update the answer for day 2 in output array and push the current day to the stack. Current day is pointing to day 7. 73 is greater than 76. No. Push the current day to the stack. We're done with traversing the input array. In the end, in the stack we have 76 and 73. Day 6 and day 7. That means there is no warmer temperature for these 2 days. So for day 6 and 7 default values will remain as it is. 0 0. Now we understood the solution in detail. Let's implement it. Copied the method signature from LeetCode. Input is integer array and output is also integer array. Let's initialize the output array and empty stack. Return result. Let's write the actual logic to populate the result. Step 1 is traverse the input array from left to right. Current day is 0, so for first day simply add this day to the stack as we haven't found the warmer day for this day yet. For second day, let's check if the current day is warmer than previous days. To check this, we'll use this logic. So while stack is not empty and current day temperature is greater than previous day temperature. If it is, that means we have found the warmer day for previous day. So in that case, let's pop previous day from the stack. Calculate the difference in dates. Current day minus. And store the result in result array for previous day. And finally, push the current day to the stack because we have not found the warmer temperature for current day, and repeat this logic for remaining days. And in the end, return result. That's all. Let's test this solution. Let's run the code. Sample test cases pass. Let's submit. Awesome, accepted. All test cases pass. Let's talk about time and space complexity. So time and space complexity for this solution is O of n, because we are traversing the input array only once, and also each index is pushed and popped from the stack at most once. So it is fast, clean and efficient. And that is how you solve the daily temperatures problem efficiently using a stack. If you found this video helpful, don't forget to like and subscribe for more coding tutorials. Leave any questions or suggestions in the comments below, and I will see you in the next video.